To start our discussion with a declarative sentence. So when I say declarative sentence, it is a type of sentence that states or declares a fact, argument, or idea without requiring either an answer or action from the reader. So these are examples of declarative sentences. The first one is Muscat is the capital of Oman. And here we have an inequality, and this talks about the 43rd president of USA. So the first three are actually true, but the fourth one is not true. It is false because we mentioned here that for every natural numbers start from 1 until infinity, or counting number. So if you're going to use 1, for example, here, it's equal to 4. It's not equal to 7, so it is false. But if we're going to say x is equal to 4, then this particular statement is going to be true. Okay, so actually, we talk about declarative sentences here because it is the only sentence in the world that can have a truth value. But not all declarative sentences can be assigned true or false. Okay, so a particular declarative sentence with which we can assign a truth value, that means true or false, is called as a proposition, or we also call this as a statement. So a statement or a proposition is a sentence that can be either true or false. So these are examples of declarative sentences, which are propositions. These are all statements because we can assign true or false, like the first one. It is true. The second one is false because it is hot. Okay. And this is an equation which is true. It rains in Dubai is also a statement or a proposition because it is true. Okay. Rains here is simple present. It means that rain exists in this particular city. Okay. So let's proceed now to compound propositions. When I say compound, it's a combination of two or more propositions. And usually to do that, we have to use connectives, or in logic, we call this as logical operators. The most common logical operators are and, or, and not. Okay. Not actually is just the negation of the original statement. So and has this symbol, and it means the conjunction of two or more statements. Actually, so if you have P and Q here, so this is the conjunction of P and Q. This symbol means or. It is the disjunction of P and Q. And it is also known as the inclusive or. All right, so these are the three, or the first three logical operators, which are very, very common. So the first three sentences here are simple. Simple propositions mean that it has only one, they have only one sentence. Okay? We cannot break it down into other sentences. So we use simple propositions to form compound propositions or propositional forms. Okay, so like the first one, A and B. Our A is Muscat is part of Oman. That is our A. And the sun is cold is our B. So this is our connective, our logical operator, the and. The second one is using or, so either A, mascot is part of woman, or it rains in Dubai, that is our C. So look at the given simple propositions above. These are used to form all of these compound propositions here below. We have here not B. So the sun is not cold. And it rains in Dubai, that is our C. Okay. The last one here involves three propositions A, B, and C. So our A is mascot is part of woman. And this is a whole group, whole quantity of B or C. So either the sun is cold, that is our B, or it rains in Dubai, our C. Okay. So these are the formulas actually that you have to memorize. For not is very simple. Not true equals false. Not false equals true, of course. When I say Dubai is the capital of UAE, this one is not true. So this is actually false. Okay, so it is false because it is not true. For or, there are three T's there, okay, including both, because this is inclusive or. Okay, true or true is true. True or false is true. False or true is true. And false or false equals false. Okay. All right, so let's proceed to the next. Here we have and. For or, we have only one false. The rest is true. Even if you have more like this, for example, true or false or false or false, the answer will be true because at least one. Okay, if there exists true, the whole form will be true. Here is the opposite. If there exists false, automatically it's going to be false. So there is only one true there. That is true and true. For example, the first here statement, Muscat is part of Oman, it is true. And the sun is cold is false. So the whole statement is going to be wrong. Okay, so number one there actually is false because not both are true. The sun is cold is false. Okay. The second one is easy to solve actually by just looking at this form, A or C. Change A to the truth value. Our A is true. Muscat is part of Oman. The sun is cold is false. It rains in Dubai is true. So our A is true or C. Okay, so our C is actually also true. So the answer here will be true. So the second statement is true. The first statement is false. Okay? Because here our A is true, our C is true as well. So true or true is true. For the third one, the sun is not cold, which is true. And it rains in Dubai is also true. So the answer is true as well. Because you have true and true equals true. The sun is not cold. Sun is hot. So it is true. And it rains in Dubai is true. So it becomes true. Let's try to answer number 4. Number 4, we can write our form and change the letters to the truth values. This is true, this is false, and this is true. So A is true and B is false or true. So we start with the inside. False or true is true. So true and true is true. So the whole statement number 4 is true. Okay, using these formulas here. Okay, so let's now proceed to the possible outcomes. It's very easy to identify the number of possible outcomes. Okay, if there are 2 letters, okay, 4 possible outcomes. When I say letters, these letters or small letters, usually we use capital letters. These are the propositions I'm talking about. Okay, so we use always base 2 here, binary, because in every statement or proposition, there are 2 possible outcomes. Either it is true or false. Okay, so every time we mention one sentence or one proposition, for example, A1 is greater than 0, this is our proposition, it could be either true or false. There are 2 possibilities, yes? That's why we use 2 here. So this one is true. 1 is greater than 0. But there are 2 possibilities every time, but there is only one answer, okay? So the formula is 2 raised to the power of n. N here is the number of propositions or the number of statements. So let's have some examples here. For example, our sentence is only 1. So there are 2 possible outcomes, either true or false. The earth is round. Only 1 sentence. The answer is true, but there are 2 possible outcomes. It might be true or false, because I might change A to like this. 1 is less than 0. Instead of saying the earth is round. So here the answer is false. Yeah. So A here could be any statement, and it can be either true or false. Now for the second one, here we have 2 letters, A and B, 2 propositions. The first one is the earth is round and it rains in Oman. So there are 4 possibilities. 1, 2, 3, 4. So the first column is TTFF. We multiply this by 2. So we have 2 T's and 2 F's. And the last is always true, false, true, false. So what does this mean? This means that it could be that the first is true and the second is true. It could be that the first statement is true and the second is false. Okay? It could be that the first is false, the second is true, or it could be both false. So these are just the possibilities, these 4. But there is only one answer every time. So here the earth is round is true. It rains in Oman is true. So the answer is TT. But if I'm going to say like this, the earth is round, and B, I'm going to change a little bit. I'm going to say it does not rain in Oman. So this becomes false. Okay, this is true. So it becomes TF. So every time we change these two statements, it might be this or the second, third, or fourth. These are all the possibilities. Now let's have three letters. We have letter A, B, and C. So we have three propositions or three statements. So 2 cubed equals 8 possible outcomes. So here we have 8 possible outcomes for our A, B, and C. So what do? We multiply this by 2 here as well to get our first two columns here. The last is always TF, 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 TF. Okay, so multiply this by 2. That's why we have here 4 T's and here times 2. So we have 4 F's here. This one times 2. That's why we have 2 T's, 2 F's, 2 T's again, and 2 F's. And the last, as I said, is always TF, TF until the end. So what does this mean? This means that it could be that the first is true, the second is true, and the last is true. So like our example, this is true, and this is true as well. Okay? So it keeps on changing. If I'm going to retain this 2 and change this to 1 is less than 0, this is going to be false. So it's going to be the second one. Or it might be F, F, F. If I'm going to say the earth is not round, here I'm going to say the earth is not round, it does not rain in Oman, and 1 less than 0. Okay, here I'm going to say it does not rain in Oman. This is gonna be false. And here I'm going to say the earth is not round. So it's going to be F, F, and F. The last one. Okay. So that's the meaning of that. It keeps on changing depending on the propositions. So these are basic laws you have to familiarize. Okay. For example, here, when we change the order of P and Q, it does not change actually the truth value. P or Q is equivalent. This is equivalent to Q or P. Same with P and Q. It is equivalent to Q and P is equal. There's no difference. Or we can change the groupings. It will not change the answer. Or we can distribute. If you have P or Q and R, distribute this inside so it becomes P or Q. And this will be in the middle. And then inside P or R. Okay. That is for 3A. So P or the quantity of Q and R, it becomes P or Q and P or R. So the first two talked about commutative laws. Second one is the associative. We change the groupings. This one is distributive. Okay, now 4A and 4B actually is P or contradiction is equal to itself. P and tautology is equal to itself. So when we have the 0, that is contradiction. When we talk about these laws here, and one is tautology. When I say tautology, the last column, all the outcomes are true, all true. This one, all false. So let's try to prove 4a. P or contradiction is equal to P. So P, there's only one. So 2 raised to the power of 1, we have 2 possible outcomes. Okay, so our P is either true or false. And then here we're going to write our contradiction, 0. That is false, false. So P or contradiction, it's like, 0 or O italicized. Somehow it's like that. Okay, doesn't look good. Okay, this is our contradiction. This is our P. So true or false is true. False or false is actually false. So look at the answer. The answer is TF is equal to P. Okay, the truth values of P. So therefore, P or contradiction is equal to itself. That's the meaning of 4a. P or contradiction equals P or equivalent to P. 4b is P and I. Tautology is P. So P we have true or false. Tautology, true, true. Okay. Here contradiction is FF. And the answer P and tautology, true and true is true, false and true, false. We're going to look at the answer is equal to P, true, false. So that's the meaning of this. P and tautology is actually equal to itself. Let's now have the 5a and 5b using examples here, starting with problem 1. Now, problem 1 is about 5a. Make a truth table for this propositional form, P or not P, and tell whether it is a tautology or a contradiction. So there is only one letter here. P is repeated. This is not a letter, this is or, and this is not. So we have only one. There are two possibilities, true or false. And the second is not P. So not true is false, not false is true. P or not P, the final one, true or false is true, false or true is also true. So looking at the last column, all true. So it is a tautology. So P or not P is equal to I. I there is tautology. I or 1. Okay, so that is 5a. True or false is true because we have or here. Or false or true is true. Let's have the second one to prove we are done with this, to prove 5b. The first one, there is no not, is P and Q. There are two letters there is equal to 4. So we have P, Q. So we have true, true, false, false, true, false, true, false. These are the possible outcomes. Okay, so true, true, false, false, TF, TF, the last column. So here P and Q, true and true is true. That's true and true. True and false is false. False and true, false. False and false, false. So the last column is mixed, combination of true and false. It is a contingency. It means neither. It is neither a tautology nor a contradiction. Number 2, we are going to prove 5b, P or not P, is 0. It means contradiction. So there is only one letter there, P and not P. So P, there are two possible outcomes. And not P is opposite of P. Not true is false. Not false is true. So P and not P, you have true and false is false. And false and true, false. So look at the last column, all false. It is a contradiction. Right, so that's it. Let's proceed to problem 3. You're going to prove that not the quantity of P and Q is equivalent to not P or not Q using the first De Morgan law. Now, when you are proving, you have to prove by showing the answer on the left and showing the answer on the right. Our left has only 2 letters. So there are 4 possibilities: true, true, false, false. And the last is always true, false, true, false. So our P and Q inside, true and true is true, true and false, false and true, false and false. And not the quantity of P and Q is the opposite of this P and Q. So not true is false, not false, okay, not false, it's true. And true here. So FTTT. And here we have not P. This is for the left. And here we have for the right. Not P here is the opposite of P. So this becomes false, false, true, true. That is for not P. And not Q is the opposite of Q. So looking at our P here, we have true, true, false, false. The opposite of that is false, false, true, true. Second one is not Q on the right. Opposite of TF, TF becomes F, T, F, T. Then the whole, not P or not Q. This one. So we're going to look at these last 2 columns using OR. So false or false is false. False or true is true. True or false is true. And true or true is true. So looking at the last column, the answer is the same on the left. We have F, T, T, T. Here we have F, T, T, T. So not P and Q, the whole quantity, is equivalent to not P or not Q. We have proven that the truth values here on the left are equal to the values on the right. We have F, T, T, T. So your homework is this. You prove that this left is equivalent to the right. Okay, so that's all for today. I'm going to continue in the next video. So until the next time, bye-bye.